In this worksheet, you're asked to complete the following reactions with the formulas and the compounds. Balance them. Not all of these reactions will actually happen, so you'll need to review your rules of solubility. I will try to explain why they are soluble or insoluble or why the reaction happened or didn't happen based on those 5 rules of solubility. The first chemical reaction has us dealing with a iron to bromide and a potassium carbonate. Based on looking at some of the things, we would swing our partners do-si-do, and our first part of this would be, I like to keep my iron in the same place, and so therefore I would have iron to carbonate. When we do these, it is still important to pay attention to the charges. Now, since carbonate has a positive 2 and carbonate has a negative 2 and iron has a positive 2, those charges cancel out. Now, based on our rules of solubility, we know that this reaction does happen because iron carbonate is an insoluble, meaning it forms a solid or a precipitate. Now, our other part of our reaction would give us the potassium bromide. Notice that the little 2's that are by the potassium and the bromide don't come with, and that's because of they came from the charges on the other part. Now, potassium bromide is solid, so we shouldn't have to worry about that. This does make our balancing very easy, in that it only requires a 2. Next problem, we're dealing with silver 1 nitrate, and therefore we have a silver chloride if we swing our partners do-si-do. Now again, paying attention to our charges, silver is a 1, chlorine is a negative 1, and therefore we have that. Now, based on our rules of solubility, this is a solid, because Rule 3 says that all halides are soluble except for silver, mercury, and lead. And therefore, this reaction does happen. The other part that still happens is our copper 2 nitrate. Now I'm putting the nitrate in parentheses because of the copper 2. Now we have to balance this out, and when we do so, we need to put a 2 in front of my silver chloride, and to balance out my silver and nitrate now, I put a 2 there. Not with that number 2 though. Next problem, we have lead 2 nitrate and a hydroiodic acid or hydrogen iodide. And when we look at this, again, we keep one thing in the same place, and I like to keep my lead in the same place, and that we have a lead 2, don't need to put this one in parentheses, as that it is not a that's not an eraser. It is not a for some weird reason that's not going anywhere. Oh well. Lead 2 iodide, and that is our solid, being that it does make a precipitate. The other part is our nitric acid would be formed, HNO3, and we now need to balance this. I will need to put a 2 in front of the hydrogen and iodide and the hydrogen nitrate. Again, next problem, we have a barium chlorate and sulfuric acid. If we swing our partners do-si-do, we're going to get a barium sulfate, and I'm paying attention to my charges. I don't have a 2 on the outside of the sulfate because sulfate has a negative 2 charge. And now barium sulfate, if we look and remember that all sulfates are soluble except for the heavy group 2, and well, barium's in the heavy group 2. It's near the bottom, it's heavy. And we get the chloric acid, and we have HClO3. So barium sulfate makes that a solid. Need to balance this out, and now we can see that, okay, I need 2 here, and we're done. 2 in front of that. And next problem is the copper 2 sulfide. Swing our partners do, Cu, Cl2, and potassium sulfide. But if we pay attention to our rules of solubility, we'll see that this reaction does not happen because copper 2 chloride is soluble and because of group 1. So none of this is necessary in our no reaction. How do I spell it? No RXN. No reaction. Because nothing's going to happen. Next problem, we have a sodium phosphate mixing with the magnesium sulfate. Now if I look and I do my sodium, the 2 will be coming from the sulfate. That's going to be soluble because it's got a group 1 element on it. The magnesium phosphate is part of that rule number 5 that says that all other salts are insoluble. And so this is our solid. So therefore, we actually have to balance it. Oh, darn. And then we go through in that process, and now I need a 2 in front of my sodium phosphate. I need a 3 in front of my sodium sulfate, and a 3 instead of my magnesium sulfate will balance everything out. And the last one on this page has us dealing with a net lead sulfate and a potentially on that. So just from the simple fact that it's a lead 2 sulfate, I know that this reaction is going to happen. Chances are if it has lead in it, it's going to make a reaction, unless it has that rule number 2 in it. And that's your acetates and nitrates. And so we have our nitric acid. Now we need to balance it, and it balances very easily by putting a 2 in front of the nitric acid. Longer page, and we have an iron 3 chloride and a iron and a hydrosulfuric acid, or hydrogen sulfide. Not something I would suggest breathing in. Not very nice. And since we're dealing with an iron 2 sulfide on this side, I don't have to worry about charges crisscrossing, and that's going to be my solid, and the other is going to be what will look like hydrochloric acid. Now I do need to balance this, but again, very nicely, easily done. This next problem, I'm going to make life easy for us, and we'll recognize that both potassium and hydrogen are in group 1, and therefore no reaction will happen. Now you'd think the same thing in number 10, but unfortunately this one has us dealing with something that's called a neutralization reaction, and therefore we have an acid and hydrochloric acid, and a base and sodium hydroxide. So this reaction actually does happen, and I'm going to write it a little bit differently. And then I'm going to write the sodium chloride, that's a salt, and the H2O. Now the reason why this one happens is the fact that we make H2O liquid, and that is the equivalent of what would almost be a precipitate. It's not going to look like a precipitate, but it is something different, and it would look maybe a little bit easier if we did a net ionic equation, but we're not going to do that at this time. The next one we would look at would be an iron hydroxide, knowing my rules of solubility, and that rule number 5 says that all other ions are insoluble. I have an iron 3 hydroxide, and therefore that's my precipitate. Now barium bromide, it could very well be almost a precipitate. Barium is a very interesting ion. It tends to form precipitates, and it could have formed a precipitate, a false positive, if you will, based on experimental evidence. But for this case, we're not worried about that. So we need to balance this out. I have 2 hydroxides, gives me 3 and 2 and 3. And so my balancing of my chemical reactions goes through that whole process of each one going in his balance. Next one, we have an iron 3 chloride, and again, I know I'm going to have a reaction because I have this iron 3 phosphate. Now, good thing we're not calculating atomic mass at this moment in time, and that's because this would be a massive one, and that's going to be our solid right there, plus our sodium chloride. Oh, I made a mistake. I don't need that there. I just noticed that my charges cancel out and now we just very well balance it by putting a 3 in front of the sodium chloride. Next one, again, I have a calcium chloride. Now that's not going to be my balance. It's not going to be my precipitate, but the iron 2 sulfide is going to be my thing that does need to be balanced. Putting a 2 here, 2 there. Oh wait. Yep, I'll balance that out. Why did I need that 2 there for? Apparently I was thinking wrong, and that it is balanced as it is written. Sometimes you start balancing and you notice, wait a second, why did I start balancing it? It doesn't need balancing. The fact that this reaction does happen and that is my precipitate. So, hey, even I look at it going, that doesn't make sense. And now we have another reaction that is going to form an only soluble salts, because we would have a calcium chloride, definitely soluble, rule number 3, and a hydrogen sulfide, or hydrosulfuric acid, I don't really care for that name, that is also going to be soluble. So everything is going to be soluble. And look, another one. Rule 1, both of them have rule 1 involved, and therefore no reaction. Another type of problem where I have a rule 1, no reaction. A ammonium hydroxide, though a base, is still soluble, and potassium chloride is also as that. Same thing on the next one, 2 rule 1s, no reaction. Now the next one, I have, a lot of people will think, well, lead and that I have a acetate, rule number 2, acetates and nitrates, but then you have to worry about something, is that you actually have lead 2 iodide, and that's going to be your precipitate, lead, mercury, and silver, rule number 3. And therefore we actually have a chemical reaction that does happen. Now it does require us to balance this out, and therefore I'll put a 2 in front of my potassium iodide and a 2 in front of my potassium acetate. Again, we look at here. Now this one's kind of tricky, where you have an ammonium chloride, definitely soluble. You have a barium hydroxide, which according to the rules is supposed to be soluble. There is experimental evidence that if the conditions are right, that it will actually come out of solution, and getting a barium hydroxide into solution is not the easiest thing to do in chemistry. But nevertheless, based on our rules that we're studying, and that's what we're going to worry about, a lot of this is just based on the rules. Can you follow the rules? We're going to say that it's no reaction. We'll get into what happens in real world situations later. So right now it's learning the rules. Can you follow them? Can you balance the chemical reaction? Next problem, we have a nitrate and a calcium sulfate. Should be your precipitate on that one. So we have a calcium, and I got a sulfate, should be my precipitate. Sometimes it doesn't like to go into precipitate. Sometimes it will kind of hang out a little bit of different, changing the temperature, or a little bit of mixing is required, but nevertheless it does go when it should. So I need to balance it, and I put a 2 in front of my sodium nitrate. Here we have a silver nitrate mixing with a sodium carbonate, which I think based on our rules we talk about carbonates making precipitates, and that's what we go with. But if I wrote it out in the same order, and that's swing my partner's do-si-do, I would say, oh look, no reaction is going to happen because I have a sodium nitrate. Yes, but it's not always the first one, and so that I have a silver nitrate, but this one becomes a silver carbonate. And I put the 2 on the silver because I have the charges of carbonate to worry about. Now I need to worry about balancing it by putting a 2 in front of my sodium nitrate and a 2 in front of my silver nitrate. And she should be balanced. Next one, I have a kind of an unorthodox reaction, and sometimes that's what we just do. Can you follow the rules? And so we go through and say, okay, I have a zinc carbonate. Wait a second, according to my rule number 5, all salts are insoluble. This is going to be my precipitate, and then I'm going to have my potassium acetate as my part of my aqueous solution. Need to balance it, but for the most part pretty easily balanced by just putting the coefficient of 2 in front of the potassium acetate. Next one, we have a real interesting one, is you have a mercury 1 nitrate. Mercury 1, as if you remember back to our naming unit, is actually diatomic and has a +2 charge. Really just boggles most students' minds, and is kind of there as a good hard problem to kind of throw at somebody who thinks they know what everything's going on. And sometimes that's just what chemistry teachers do. And just, can you remember some of those little finite details? And so we have this looking at, again, a chemical reaction does happen. My mercury most likely will always come out of solution, and therefore I have that as my soluble. Even though in the rules we only had 3 exceptions, mercury would be one of the fourths, if it would if you will, and balances out pretty quick and easy by just putting a 2 in front of this potassium nitrate. I'm sorry. Again, another one, but I have 2 nitrates. So a nitrate mixing with a nitrate, yeah, you're not going to get anything to happen. So no reaction. Now the next one, we're looking at a sulfide and stuff, and so I have this hydrogen, and it'll be an acetate, which is acetic acid, which is in its dilute form, is commonly known as vinegar, and that's going to make a cadmium 2 sulfide, CDS, and that is my precipitate. And therefore, when we look at that, we can see that I need to balance again. Pretty easily done. There it is. And so next problem, I have, again, this issue with barium, sulfate, and that's my precipitate. And sodium bromide would be my aqueous solution. Putting a 2 in front of my sodium bromide is where I get that from. Again, you're going to deal with this as well, this one is kind of acidic, and for the most part, yeah, you're right. This one's not going to come out of solution very easily. But according to the rules, and that's what we need to follow. We got to follow the rules. This reaction, calcium sulfate, should not happen based on that, but a lot of times it will. But we're going to follow the rules based as they are written, and therefore we will call it let me change my thing to just match up, a no reaction on that. Now here I have a silver nitrate mixing with the hydrochloric acid. This is almost a given that this is going to happen. Silver loves chlorine and will bond with it so quickly and easily. It's actually very difficult to keep out of precipitate. You have to be very mindful of how you store it. But what's really nice is that it's balanced as it's written. Yay! The next one you have, this is one where you're going to look at it. It's like, well, this should be the reaction that I normally would get. And a lot of people would say, well, I'm going to get a calcium chloride soluble, and I'm going to get I'm going to write it in the correct color because it's not right. A lot of people would guess that they're going to get a carbonic acid. Yeah, that's not going to happen. If you remember back from earth science, you might have done in the mineral testing, you've taken a limestone and put a dilute acid on it, and in that case, you got H2O liquid, and that bubbly fizzing stuff. If you remember back to, does a chemical reaction actually happen? Well, you bubbled and fizzed. Something happened. You had a chemical reaction. and that formed a gas. So this reaction does happen, so you need to take that into account. We do still have to balance it, but for the most part, that's all it requires. In the next problem, we have a iron chloride and a hydrogen sulfide. No reaction is going to happen on that one. You have iron mixing with chlorine. No reaction should happen. Hydrogen sulfide shouldn't happen anything there as well. In the next problem, we have a sodium sulfite, and that goes to 2 sulfite, and that should make a reaction because you get the aluminum hydroxide to form. And that will be your precipitate. The balancing might get a little messy at times, and that's kind of just going to happen. So you have to put a 3. Ooh, that should be a 3 there. There. That might make things a little bit easier. We need a 2 in front of the aluminum over here. That means that I have 6 of those. I'll also need a 3 to balance out my sulfites. But that actually makes things very easy. All I need is a 6 in front of my sodium hydroxide to balance it out. Now it looks like 316, but it's the numbering. And on the last page, we have again, to start off with, no reaction. I have a sodium, I have a hydrogen. They're not going to create anything. Next one does happen, and you have a hydrogen mixing with sulfate. That's not what it is. It's the copper. Make that U a little bit better. The copper sulfide, copper 2 sulfide, is going to make actually happen. And so, but it's balanced, but that would be our precipitate or solid. Again, in the next one, we have another reaction where we have a potassium sulfate here. And this happens because, not because of the potassium sulfate, because of our mercury chloride. As we saw, mercury tends to be an exception to a lot of the rules, and there it is. And we do have to balance this guy out, but balancing it out with a 2 in front of the potassium chloride on the other side helps us out a bit. Next problem, I have ammonia. A lot of us would say, well, anything I mix with ammonia is going to be soluble, and you are correct. So that just means that this is not our insoluble salt. Instead, what becomes our insoluble salt is the lead chloride, lead 2 chloride more specifically. That is our insoluble salt, and therefore we need to balance this, putting a 2 in front of my ammonium chloride and a 2 in front of my ammonium acetate will make this balanced. Now again, this is good practice. Hopefully you got some of the answers correct. Hopefully if you didn't, you saw what you did wrong, and you can correct them.